Okay, this video looks at the y-intercept. The y-intercept is where the graph cuts the y-axis. From a rule, we can work out the y-intercept without having to sketch that graph. If the equation is in the form y equals mx plus c, this constant term c represents the y-intercept. So if we had y equals 2x plus 7, the constant term, that is the term without the x, is our y-intercept. So y-intercept is given the reference of c. So c stands for y-intercept. Our previous knowledge, remember that the coefficient with the x is our gradient. So we could write from this that our gradient is 2. Let's look at the examples from the textbook. Y is equal to negative 4x plus 7. Remembering our y-intercept is the constant term. There, so our y-intercept is 7. Our next example, so that's A, B. 5y plus 2x is equal to 10. We need to rearrange this formula because we need it in the form y equals mx plus c to work out the y-intercept, just like we did for the gradient. So I'm going to subtract 2x from both sides, so that cancels. So I've got 5y is equal to 10, subtract 2x. I now need to divide by 5, so I've just got y, divide both things by 5. So y is equal to 2, because 10 divided by 5 is 2, subtract 2x over 5. It's now in the form y equals mx plus c. The y is on its own on the left-hand side. The term with the x is on the right-hand side, and the constant term is on the right-hand side. And remember, our constant term is our y-intercept, so our y-intercept is 2. When we write our y-intercept, we can either write it like that, c equals 7, c equals 2, or we can write it like this. X is 0, because for the y-intercept, for where this line cuts the y-axis, x is always 0. So 0, 7, 0, 2. Okay, let's look at our third example. Y is equal to 2x. Alright, we can write 2x plus 0, so there's nothing added to the 2x. Remember, our constant term is the y-intercept, so there's our y-intercept. Our y-intercept is 0. So x is 0 and y is 0. Our last example, D, says y equals negative 8. I can, to help you understand this, write that there is no x term, subtract 8. Remember, our constant term is our y-intercept, so our y-intercept is negative 8, or x0, y negative 8. So just a reminder, the point where the graph cuts the y-axis is called the y-intercept. At the y-intercept, x is always 0. If we've got it written in the form y equals mx plus c, the constant term, the c, represents the y-intercept of the line. It needs to be in the form y equals mx plus c, like worked example A. If it's not in that form, like worked example B, we need to rearrange our formula before we can work out what our y-intercept is.